So we're just going to start off with some synthesis reactions. And we want to turn this into two pretty similar products here. And they start off pretty similar, but diverge kind of quickly. So here's your double bond on this one. Here's your double bond on this product. We call that 1 and this one 2. And to make this alcohol more useful, you can attack it with PCC, and you're going to get this. And what's different between this one and this one, this can easily be created with triphenylphosphine. Hit it like that, PH3P. My arrow's kind of in the way. Like that. And that's how you do that one. But it's a much easier process to not make this for the second product. Instead, you can hit it with Grignard. So BR, MG, and then your R group. And you'll need H2O here. So 1, 2. And that doesn't quite get you there, but it makes you pretty freaking close. You're going to have this OH, and that's kind of a simple fix. To get rid of that, you're only going to use POCl3 and pyridine. And if you're curious what pyridine is, it's N, like that. And, you know, there you go. So that's that one. We can move to the second reaction. We're going to turn this into this one. Draw that a little more neatly. And the real change here is that you have this, is that you have this, like OH is moved up, you're putting a carbon in there, and anything that can mess with this, they can pull this O and do anything with that, it's going to mess with that, that double bonded oxygen. And so you're going to want to use, you're going to want to protect it. And a really easy way to protect it is to just use something like that. Protect. And that's going to create OH. Again, apologies for the bad handwriting. Just like we did up here, PCC makes OH more useful. You can make this useful, PCC, and you're going to get that. My roommates are watching TV. Here, PH3P. Sometimes you don't actually have to draw the H's, but it makes it more clear. Triphenylphosphine, just like we hit this one, we're going to hit this one. And that's going to give us that right there. Then the next step is really just, now this is getting a little wild here, but BH3 first, there are some, you know, some hydrogens and that sort of thing in the mix, and then H2O, H2O2, so hydrogen peroxide, and OH minus, and that's in your second step. And that's going to make that into useful, that shape. Here you have your H, excuse me, here you have your H, there you too, of course, but the last thing is to deprotect, and you can do that pretty simply using H2O and, you know, H plus, some sort of mild acid, kind of. And there's your product. and that just, again, deprotecting gets rid of that double bond. So the last one, just so that we're kind of short on time here, we're going to use OH. Okay, this guy. They're cheering for me. No, I'm kidding. If you can hear the TV. OH. HO. And, you know, the real change is happening here. But ironically, yeah, I mean, you can just hit that with the Grignard. But it can sometimes mess up the OH. So you'll want to protect this and hit it with TBD MSCL. So, and basically, CL is going to switch places with that right there. They're going to, you know, get together. And TBDMS is going to, it's basically you're going to make TBDMSO. And there you go. And then hit it with your Grignard. It's always important to have water with your Grignard. Alright, and here you're at your, you're at your product almost. This one's kind of simple, just deprotect with TBAF, and there you go.